Let's get started, and let's get started with about talking about events in Angular that, yeah, might sound like pretty simple topic, but if you start diving into it, into entire this system and Angular, how Angular process it, this system is actually quite complicated and. Yeah, I'm here to a little bit clarify it, and I would like to show you how this whole system works under the hood without diving too much because it's too big topic. But anyway, I think we will find some gems that we will be able to apply in the real life applications. So usually I deliver this talk like offline, and I like to start with a question about the following code. Like, what do you think would be the output of this simple piece of Angular code that we on the daily basis write in our text editors? And since yeah, we are not unfortunately on the offline event, I cannot hear your answers, but you can type your answers to comments if you want. But I will proceed with the solution, and eventually, after all the magic compilation and other stuff, we will get simple JavaScript, vanilla JavaScript. It will be a simple add event listener attached to certain elements, and our handler will be eventually involved as a handler, right? And this is like very short version of it, but I would like to show you more in details how we go from that part, from the source code to this vanilla JavaScript stuff. And in the next 30 minutes or so, we will have a look at this event setup pipeline. Then we will take a look at the event management plugin system. It is actually the main thing I would like to share with you, but I would like to show you how this system looks within the bigger event management system in Angular, so you see the entire picture. And eventually, I will show you how this everything works in practice, why do we need it, and how you can apply it to your Angular applications. So yeah, let's get started with the event setup pipeline. And quick note before is that you might have a feeling that this is some never-ending story because we will be going through a lot of abstraction layers. But I promise eventually we will reach the final point. And our journey starts from actually compilation phase, because the code we write in our editors, it is different from what will be eventually executed in browser. So it needs the compilation phase, and our templates in components, our component templates after compilation look like this. They are transpiled into a set of small functions that are in context of Ivy Angular renderer. They're called instructions. But the point is that those are functions that do a little piece of work, like create a DOM element, create a text node, or create property binding, etc., etc. And event bindings, they have a dedicated instruction as well. And it is called DOM listener. This is a private function. You cannot use it in your application code. But anyway, so there is such a function, and this function will be involved at the point when the component template is being initialized. So when component is created, the template function is executed, and this DOM listener function will be involved. And now let's follow the call stack and see what happens inside. So inside this function, there will happen a lot of actually things. I dropped most of them because there are a lot of edge cases that needs to be covered. For example, Angular checks if we listen to output, component outputs, or it's a DOM event, and they have to be handled slightly differently. But anyway, eventually, if we have to deal, or if Angular has to deal with DOM event, we will reach this listen to DOM event function. And here happens a few interesting things. The first thing is here. We resolve the component renderer. And renderer, this is a guy that is responsible for rendering your template. So, I mean, create DOM nodes and apply styles. You probably know renderer, namely renderer 2, and you probably heard about it in the context that you have to never manipulate DOM nodes directly in Angular. You should use a renderer for that. This is outdated recommendation, but it exists, and probably you might know about renderer from there. But we resolve this part, and we also wrap additionally our listener function, so our event handler. And we wrap it, in this wrapper brings actually a couple of useful things. First of all, it automatically marks view as dirty, so you don't have to manually do that if you use on push change detection strategy. Yeah, so for event handlers, it makes no sense to call mark for check there because it is done automatically. And also, it wraps everything into a switch case, big switch case, and properly handles errors and delegates the error code errors to global Angular event error handler. So some things to simplify our life. Yeah, they happen here. And after that, we have to go down and down to the following the call stack, and we have to resolve the target, meaning that we have to resolve the DOM node where the event listener has to be attached to. And then, since we already resolved the renderer, we have everything to delegate the event listener setup to render. And this is what a renderer is supposed to do. However, render, this is the first our abstraction layer. Renderer is not really doesn't really do this job of the event listener setup. Instead, it injects so-called EventManager. We will talk about it a little bit later. And additionally, it wraps our callback with one more wrapper, and this wrapper brings the behavior, namely when you return false from your event handler, it is equivalent to prevent default. And this is syntax as sugar that Angular does for you, and this functionality activated exactly in that line of code. Because in vanilla JavaScript, if you return false from the event listener, it will be just ignored, right? And then when our handler is ready and wrapped with everything that it needs, we delegate the further processing to EventManager by calling the add event listener. But inside the manager, again, manager doesn't do exact job. It delegates it to plugins. It is a set of classes you will see later that are responsible for actual event listener setup. But before this setup happens, manager resolves the proper plugin, the plugin that supports the particular event name. And once such a plugin is resolved, then it will be delegated to this plugin, and inside the add event listener of that plugin, there will be executed already the event listener setup using the like native add event listener method. Besides that, there is important method called supports, which helps manager to understand if this particular plugin can handle a certain event, right? And this is what is being called inside the find plugin for method of the manager plugin. And in such a way, Angular knows which event, which plugin can be used for a particular event. So why it is so complex, actually? Well, if we zoom it out a little bit, we can say that every step actually makes sense, because compilation phase, we need to make everything executable in the browser. Listener wrapping layer, we need to bring some additional logic to our event handlers to not do a lot of things manually. The renderer layer is necessary because Angular components, they can be created in different encapsulation modes. For example, the encapsulation none, shadow DOM, emulated encapsulation, view encapsulation modes. And for every of these modes, specific render is responsible. Or if you use legacy animations in your component, it will be rendered by a specific renderer too, which knows how to process custom animation events like event start, event done, and so on. Because those events, they are Angular specific, and they have to be processed by animation engine instead of the like regular DOM DOM events, and those things needs to be resolved at this stage. And then we have the event manager layer that is responsible for the final part of the entire work and set up listeners to the DOM elements. But still, like event manager, it's also not a simple simple system. It has not a simple architecture as well. So if we visualize it, yeah, we have a manager and the group of plugins that needed for whatever reasons. But what are those reasons? The thing is that we can handle different type of events in Angular. We can handle simple event like key down, click, mouse enter, mouse leave, etc., etc. I consider them as a simple events. And Event Manager delegated to the DOM events plugin, plugin that knows how to work with these simple events. And this plugin is built in, and it handles the vast majority of event bindings in your application. Yeah, most of them are handled by this plugin. But we also can use things like this. So something like hotkeys. And you can do it in Angular without any additional configuration, actually. So if you didn't know that it's possible, yeah, it's possible, and you can use it. It's pretty old feature. And this type of events, like this hotkey event, it will be handled by another key event plugin that knows how to handle exactly this type of events. And it is also built in, and that's why you can use it already now in your applications. And it means, and the cool thing about this everything is that this plugins system is extensible. So it means that we can write our own plugins that can handle our custom events. For example, we can debounce, I don't know, key down or click events or anything like that. And for that, we can create a dedicated plugin, which we are going to do right now together. So it's time for a quick demo that I prepared. Hopefully you still see it. So here's my demo application. And it's a simple live search. So I can type anything, and I load data from the server based on the user search. And it happens too often, like every time I type something into the input, the data is loaded, which might be not so efficient. So I would like to, for example, debounce the input event. So how we can do that? First of all, we have to agree on the syntax, how the syntax would look like. So here, use your imagination. I will use something like input.debounce. And I want to have something like this. Yeah, 2 seconds, or maybe I want to define 5 seconds, or I want to maybe define it as milliseconds, like that. But yeah, let's agree on syntax like this. Once you do that, you have to create a plugin and register it. And registration of the plugin happens inside the app.config.ts file. So it's pretty easy to do. You just provide it as a EventManager plugins token. It is a multi-provider, so make sure that you use multi-configuration here, and you have to provide a class that contains your custom logic that needs to be executed during the event handling. And I created actually such a class. Here you can see, and we will walk through together and make this current code actually useful. So first of all, what we have to do is to activate this plugin for that our custom event, right? So that's why we have to call this supports method, which receives the event name, and event name will contain actually my entire string here, right? So this is something we will get as an argument, and depending on that, I have to return true or false. And if I return true, it will activate this plugin for me. For that, I use this simple regexp, and it just checks if this debounce substring is present in the string I get. And if it's present, I say that, okay, this plugin knows how to deal with events that contain this string in the event name. And when activation of the plugin happens, we execute the logic right here inside the add event listener. And what we have to do there, we have to actually create event listener for our handler, but we need to bring this additional debouncing logic to our handler. And to achieve that, we first of all would need to split our full event, like input debounce to 2 seconds whatsoever, into the array of values, and then we can assign and resolve from it the original event we actually want to listen to, which is my input, right? Because those things, those are mostly like decorators and configuration stuff, but the original event we want to listen to is the input, right? And this is what we resolve right here. The next step would be to customize our event handler, because this is our handler we define in the component template, right? So this is what we get here, and I wrap it with the debounce function that actually I can show you. It's just simple JavaScript code that simulates the debounce behavior of the RxJS. Of course, you could use RxJS here if you want, yeah, but I decided to not overcomplicate things and just created this simple function. And also what I do, I just calculate the duration based on the parameter I get right here. And it also, like, it's simple but yet complicated a bit because of this regexp. But the general idea is that it will simply take the string I get here and it will divide it to the actual time number and the unit that like represents seconds, milliseconds, whatsoever. And then yeah, I get those values. I can resolve them from the match group. They will be resolved in the following object. I can destructure it, and then based on the unit, I can already resolve the value for that represents milliseconds for the delay represented in milliseconds. Sorry, yeah. So if it's a second, we just multiply it to 1000 and convert it to milliseconds, and then we provide everything to the debounce function, and in such a way we get a debounced event. After that, we have pretty much everything to create our event, our native event listener for the input event, and we provide our wrapped handler, which is eventually our handler that brings the debounce logic. And the last step we have to do is to clean up things, because otherwise we will get a memory leak. And the cleanup logic is executed in the function that the add event listener should return. Yeah, so I do it like this. I can remove that part, and I simply return remove event listener and provide which exactly listener needs to be removed. As easy as that. What else I could? We can actually check if everything works, right? So we can try to type something. Then you see we have 2 seconds delay, and nothing happens because I think I didn't save something. Yeah, I forgot to save the app config. So let's try it once again. I type, 2 seconds delay, and then my data is rendered actually. So this is the way you can debounce DOM events. Alternatively, what you can do to simplify things here, you can also use the reference to the manager, to the event manager, that every event manager plugin inherits, because you extend the base class. This is what you actually have to do. And it has add event listener, and you can actually delegate the further processing to the manager. And you can provide element, event name, and handler. So let's do that. With the element, so we can provide element. Then we have to provide event name. And the last but not least, it's our wrapped handler, right? So we can provide it like this and simply return this thing like that. And this thing we can remove. And what we did here is actually we wrapped our handler with the additional logic. We brought this debouncing functionality, and then we just propagated it back to the manager and say that, okay, you know, manager, we have such an element to attach the event to. We have the event name. Sorry, we have to provide the original event name. So we have the input event, so you can delegate it to the built-in Angular plugin that handles these simple events. And we have the following wrapper that needs to be executed. So please execute it. And it will set up the handler with our custom handler for that input event, and will care about cleaning up stuff, because it will be processed by the built-in plugin, and things supposed to work as before. We type 2 seconds, and everything remains working. So this is pretty much everything I would like to share. There are many use cases where I think it could be useful. So the feature is pretty old, actually, but not well known. And you can use it even in old Angular applications if you want. And thank you very much for your attention.
Okay, thank you, Dmytro, for your talk and for the valuable insights. And I guess we should now jump to our Q&A session. So again, guys, this is your last chance to put your questions to the chat. Let me see if we have anything in there. It seems, there is one. I was just about to say that not yet, but what event-related mistakes most commonly lead to performance issues in larger scale applications?
I think here meant event-related, not only the DOM event, but in general event, like when we get, I don't know, data from HTTP via RxJS, for example. So there might happen a situation when we use RxJS, for example, and quite often we wrongly use the distinct until changed operator, especially when we deal with complex data structures like arrays and objects. And developers often make a mistake that they just compare two objects that are always false, even though they might not change. So, and it leads to re-rendering quite often, because we get a new object, new reference, and Angular would need to schedule unnecessary change detection cycles. And for that, yeah, we have to compare keys, for example, user IDs or any other key that can help us to distinguish if the object changed or not, or do deep comparison of the object depending on the use case. But yeah, such things can lead to performance degradations. And those are some of I quite often noticed in different code bases. Because sometimes you put the console log in a certain stream, and then you see that it just called, I don't know, dozens of times, and you have unnecessary calls that caused very often by exactly that use case I just described.
All right. Thank you for that. And I don't see any other questions, but maybe let me ask you one more from my side. Actually,
Sure.
maybe you will find this interesting. So last meetup, I was speaking about zoneless and in general, the changes in the change detection, also in relation to introduction of signals. And I mentioned that something which you also explained in here, that our template-bound event handlers are wrapped in some special, let's say, Angular wrappers that take care of dirty marking the component, right, for us.
Mm-hmm.
So my point was that in case of the signal-based change detection, this, let's say, semi-local one, we do not really want that sometimes, right? Because we are just changing the signal, and this alone can trigger our scheduler, but instead the whole path is marked dirty. And we are wondering if there are any nice patterns maybe we can use, like, reusable, other than like using renderer listen or like RxJS from event, pretty much something reusable, which could be utilized across the app to really opt out of this dirty marking for the components. Maybe you have some thoughts regarding this.
I'm not exactly sure, but I think when I was investigating the source code of Angular in regards of the zoneless, how it works, from what I remember, this trigger caused by the event handler, by involving event handler, will be ignored in zoneless mode. And as you mentioned, when you rely fully on signals, only the signal change causes actually the change detection, and some like other events that are not related to events. And this thing caused by event, they will be simply ignored, and at some point Angular just doesn't just exits the logic inside the change detection scheduler service. I'm actually not sure if it's 100% true, but from what I remember, it was like that.
Okay.
So that's something that works for the for the applications powered by Zone.js, but with zoneless, it's a bit different.
Yeah, so I believe I've checked this some time ago, and it was still there, for the compatibility reasons. But maybe it is like you said, maybe it got updated recently. So I had
because of the compatibility reasons, it works pretty complicated way. It's hard to figure out actually how it works there, because there are a lot of branching of how things might be processed. But if you rely only on signals, things are much easier, and the only trigger mostly is changes inside the signal when you read value inside the from the signal inside the template, and maybe some other rare events that might schedule a change detection. Because now we have a huge list of internal Angular events that trigger change detection, and we don't rely on the asynchronous stuff and Zone.js that intercepts this asynchronous stuff. So yeah.
Definitely, the world when only signals are driving our change detection is the place we all want to be. Ultimately.
Yeah.
Okay, Dmytro, thank you very much for being with us today again. And
welcome.
Thank you for your talk, for the Q&A session, and hopefully we can see each other at some future events. And take care, mate.
No problem. Thank you very much. Yeah, thanks for having me. Bye-bye.